another section of triangle congruence. This is our final section in this unit. We're going to talk about, now that we can show that triangles are congruent, once we know that the triangles are congruent, we know that all of their corresponding parts are from TC4, and we're just going to put those together in this section. So our goal here is going to be, if I want to show that two segments are congruent or two angles are congruent, or I want to show that something is the midpoint of something else, if I can show that two triangles are congruent to each other using only 3 pieces of information, well, then I know that all of the other pieces are congruent too, all the other corresponding parts. So we're going to use this acronym CPCTC. It stands for corresponding parts of congruent triangles are congruent. Now this also applies to other figures as well. Corresponding parts of congruent figures are congruent, is how we learned it in TC4. But we're going to specifically use this for triangles today. So if we know that this triangle ABC, is congruent to triangle KLM, the corresponding parts, A, K, B, and L, C, and M, are congruent, and then also their corresponding sides as well. So if I'm given this triangle, these two triangles, I'm given that we have a pair of sides that are congruent, we have another pair of sides that are congruent, and I'm trying to prove that these angles are congruent. Well, let's see what we can pick up here just by putting some markings on our picture. So AB is congruent to BD, and really there should be segment symbols above there. So AB is congruent to BD, all right, and BC is congruent to BE. And I'm trying to show that angle A is congruent to angle D. As it is right now, I can't assume that that's the case, because I don't know that these are parallel to each other. But there's one other angle that I could show is congruent. I could show that angle ABE is congruent to angle CBD, because those are vertical angles. And now I have the criteria necessary to show that these two triangles are congruent by SAS. Notice a side, an angle, and another side are congruent. And then once I know that the two triangles are congruent, then I know that their corresponding parts are as well, and I'll be able to say that A is congruent to D. So that's the plan. Show that the triangles are congruent, just like we did in the last section, and then we just go one step further and say that A is congruent to D because of CPCTC, because the corresponding parts on congruent triangles are congruent. So I'm going to do this first one as a flow proof, and then the other ones I'll do as a 2-column proof. So put our givens in their own bubbles. We're going to say, all right, AB is congruent to BD is given. It gets its own bubble. BC is congruent to BE. That's also given. That gets its own bubble. And then the next thing that we said in our proof after we marked those is those vertical angles are congruent. So angle ABE is congruent to angle DBC, because those are vertical angles, vertical. So we have the statement and the reason in their own bubbles. Those 3 things are independent of each other. They didn't have, one wasn't true because of the other one. So we don't have a flow into each other. But those 3 facts together are going to lead us to the fact that triangle ABE is congruent to triangle. And notice the order here. AB would go with DB, and then C. Okay, so BE goes with BC, BE goes with BC, and AE goes with DC, right? And that's because of SAS, by SAS. That gets its own bubble. So these 3 facts together, these 3 facts working together, make that true. And now, because we know that the triangles are congruent, we can end on our last fact here, that angle A is congruent to angle D, because angle A and angle D are corresponding parts on these congruent triangles. Corresponding parts on congruent triangles are congruent, CPCTC. Okay, so that's the thought process for each of these. We show the necessary criteria to show that the triangles are congruent, and then once we know the triangles are congruent, then we can say that the corresponding parts are. Okay, so let's take a look at the next one. So here, we're trying to prove that BC is congruent to AD. Notice there's nothing given to us here. We're going to take the markings on the diagram as given. We're trying to prove that BC is congruent to AD. Here's BC, here's AD. I'm going to guess that that's a D. So as far as what we write down for our given, we're going to write down all the markings that we have on here. So AB is congruent to CD. That was given. We have that angle BAC is congruent to, and actually I'm not going to say, yes, I'll say congruent here. These are, the marking is for right angles, and I'm actually going to write this in 2 steps. So angle BAC and angle DCA, angle BAC and angle DCA are right angles, because that's what's marked, that's given. And that's all we would need if this was an HL that we were trying to show. If we had a hypotenuse that was congruent, we'd be able to use the fact that they're right angles. We wouldn't have to say that they're congruent, just that they're right angles. But because we're trying to show that the hypotenuses are the same, I can't use HL as my congruence criteria. I need another side. And actually, I need another congruence. So not only are those right angles, but angle BAC is congruent to angle DCA, because right angles are congruent. Right angles are congruent. Right angles are congruent. That was a theorem from a previous chapter, a previous unit. Right angles are congruent. So now I have a side that we've said is congruent, an angle that we've said is congruent, and we need one more thing. The one that they share here, AC, is congruent to itself. So if AC is congruent to, and I'm going to change the order on this since A corresponds with C. Notice angle A is the right angle here, while angle C is the right angle over here. So segment AC is congruent to segment CA because of the reflexive property. Reflexive. Something's congruent to itself, that's reflexive. Now we have our 3 things. We have our congruent side, congruent angles, congruent side, angle, side. Now we're able to say that the triangles are congruent. So triangle ABC is congruent to triangle CDA. So ABC and CDA by SAS. And now we can say what we were trying to prove the whole time. Once we know the triangles are congruent, then we know that all the corresponding parts are. BC corresponds with AD. BC is congruent to AD because those are corresponding parts on congruent triangles, and they're congruent. Okay? Corresponding parts are congruent, triangles are congruent, CPCTC. So we show that the triangles are congruent, and then we just go one step further to say those parts are congruent. Let's look at one more. We're actually going to look at 2 more, this one, and then this one, and then we're going to do this last one in class together. So we're trying to show in this case that angle A is congruent to angle C. So that is not a given statement, that's what we're trying to prove. The given is the markings. So what's given here? AD is congruent to CB. That's given. That's a given marking, that's a dash mark that was already on there. And then we have that BA is congruent to DC, also given. And then the last thing we can say here is they share this side, BD would be congruent to itself. BD is congruent to, and B does correspond with D, so we're going to switch the order here, DB. BD is congruent to DB by the reflexive property. And now we've stated 3 pairs of sides that are congruent, and we can say the triangles are congruent. Triangle BD is congruent to triangle. If I started with A and then B and then D, I'm going to go C because that corresponds with A, and then D and then B. A, B, D, C, D, B. Because A, B goes with C, D. And that's by S, S, S. Now that we've stated that the triangles are congruent, we can say that those angles must be congruent too. Angle A must be congruent to angle C. Those are corresponding parts. See? Angle A and angle C are corresponding parts on these congruent triangles. So CPCTC. Okay. Show the state the necessary criteria, state the triangles are congruent, and then say that the corresponding parts are. Okay, one more. Here we're trying to prove that angle A is congruent to angle C. That is not given, that's something we're trying to prove. We're given that AB is congruent to CD. We're also given these right angle symbols, so angle ADB and angle CBD are right angles. That's given. It's a given right angle marking that's on there. And we're also, now, do I need to say that these are congruent to each other? In this case, no, because notice that AB is a hypotenuse, DC is a hypotenuse, and we're going to be able to say one more congruent side here, another pair of legs. DB is congruent to BD. So we have a hypotenuse and a leg on a right triangle. So saying that these are right angles is enough. We don't have to say that they're congruent. But we do need to say one more congruence here. That we have a hypotenuse, we just need the leg. So that BD is congruent to DB. Switch the order because D and B are the corresponding pieces, D and B. And that is the reflexive property. Reflexive, when something's congruent to itself. Notice that isn't a given marking, but something's congruent to itself reflexively. And now we have a hypotenuse and a leg. We're going to be able to say that the triangles are congruent. Triangle ABD is congruent to triangle CDB by HL. And now that we know that the triangles are congruent, we know that their corresponding parts are congruent as well. That angle A is congruent to angle C by the corresponding parts on congruent triangles are congruent. Okay, so we stated the necessary criteria, showed the triangles are congruent using one of our 5 shortcuts, and then now that we know the triangles are congruent, we say that the corresponding parts are. Always looking to end on what we're trying to prove. Now this last one we're going to get to in class. Our last thing isn't a congruence. Our last thing is show that M is the midpoint of JL. Show that M is the midpoint. So this is going to require an extra step past where we went in the previous one. So we'll talk about that in class, and I will see you then. Bye for now.